So why cloud? Why do we choose cloud as the go-to network management platform for our networks? Well, the reason is it's easier to manage large dynamic deployments using a central management system, and it's easier to manage and deploy that management system using a cloud platform. It creates operational excellence, operational cost savings, simplicity of deployment, and also it gives you the option of rolling out your deployments quicker, especially in a distributed scenario. So when you have lots of branch networks, branch sites, remote locations, or when you need to roll out a large number of devices in a short period of time or with limited staff. So let's take a look at how the Wi-Fi, or actually network management architectures, in this case Wi-Fi management architectures, evolved in the past, and why was that evolution necessary. So it all started around 20 years ago in warehouses. So Wi-Fi was first rolled out to warehouses because it was more convenient to have a handheld scanner that's not attached to any cables, to be able to go through that warehouse and scan the labels, send them to a centralized ERP system, and it was simply easier and more cost-effective to deploy and manage networks that way. It provided business benefits, immediate business benefits to the customers that were using the handheld scanner type of deployments. Now, the networks at the time were usually isolated autonomous access points that didn't share any information or any control plane with other access points. And when the number of those access points grew to a certain amount, usually there was a separate NMS system, SNMP based or something similar, that would monitor those APs. But those access points would not actively cooperate in terms of RF management, in terms of handover, in terms of security. They were just completely autonomous, isolated systems. Now, what happened with Wi-Fi is it went beyond the warehouses. So obviously that was the very first use case, but then it became apparent that having the option of mobility in an office environment actually proved to be very beneficial as well. You know, you're no longer bounded by the wire, you can move around and still be able to access all of your resources on your corporate network. So the amount of access points deployed in such a scenario was much larger than the amount of access points that you would deploy in a warehouse. You deploy a couple of access points, you'd cover the whole warehouse because all that was important there was coverage. And the application that was used on those handheld scanners didn't use a lot of bandwidth. Now, when you go to an enterprise scenario, obviously you're using different kinds of application, email, databases, and then real-time applications like voice and video. So the demand on Wi-Fi becomes much harsher, and there's more access points involved, and more importantly, the environment becomes much more dynamic. And then you need to start thinking about things like RF management, safe and fast and secure roaming. How do you consolidate all those clients? How do you make sure that they have undisturbed connectivity for end-to-end throughout your campus? And that's where something called a controller came into place. Now, the reason for deploying a controller was, at the time, the access point themselves didn't have enough resources to be able to run all of this intelligence on top of being able to provide connectivity to the client devices. So a physical controller, a physical piece of hardware, and with a dedicated piece of software, was used to manage the RF environment, provide fast and secure roaming capabilities, QoS, and also provide connectivity to the distribution system. So it would also terminate the data plane. On top of that, you'd be running a separate NMS, just like you would in a autonomous AP scenario, but the controller made it possible to manage the dynamics of the Wi-Fi network. So that's how controllers came into place. With the evolution of computing, and with the introduction of virtualization, where we'd be able to use the same physical resources for multiple applications or multiple operating systems, the physical controller, came from a dedicated server to a virtual machine. That's what we call a virtual control deployment. Obviously, that provides cost benefits because A, you can run that controller on the same hardware that you're using for your email exchange server or other types of applications. And at the same point, the hardware on the access points evolved, so the price of the CPU and memory started becoming more affordable, so we got more and more resources in the access points. And then what also happened at the same time is some of the controller functionality was actually implemented on the software running on top of the APs, and that became a hybrid AP. So for some environments like remote branches, you would run the hybrid AP to manage the dynamics of the environment within the branch, whereas the central virtualized controller would handle all the campus-based access points. With the evolution of cloud networking, that controller function was taken from your data center, from your hypervisor, from your virtualization solution to a public cloud. And that controller function would be implemented off-prem or in a public cloud environment, and the access point, that same access point would then talk to the cloud controller in order to provide RF management and fast and secure roaming. So that's how a cloud controller was born. The final and the fifth step of the evolution is a distributed control. Now, the problem when you take a controller and put it in the public cloud is you're creating a dependency on your WAN connections. In order for RF management and fast and secure roaming, QoS, application visibility and control, all these features that are needed to manage the dynamics of the Wi-Fi network to work are dependent on your WAN connections. If your WAN goes down, or if somewhere in the transit between your AP and your virtual cloud controller there's a disruption of service, you have a disruption of service on your Wi-Fi, which is not ideal. So that's the reason why distributed control was created. And distributed control keeps all the control plane local. And the only part of the system implemented in the cloud is the network management system. So the control plane stays local, there's no centralized control, there's no controller. The access points implement protocols that provide control plane functionality without having a central point of decision making. So they make all those decisions by communicating through those protocols between one another. And the cloud is only used to manage and monitor, so to configure, monitor, gather information, and if the WAN connection goes down between your site and the cloud, your network is still functional. The only thing you don't have is immediate visibility into what's going on in your network through a single pane of glass, so for that cloud platform, because there's no connection to the site. However, the access points will cache all the monitoring data, and once the WAN connectivity is established, that data is going to come back and is going to be pushed into your management system. So while you're not able to actively change any configuration during the time that you don't have WAN connectivity between the site and the cloud, everything else is still up and running. And that's the major benefit over all controller-based deployments. So you don't have any central point of failure, you don't have any central bottlenecks, everything is done locally when it comes to the data in the control plane.